Hey everyone, welcome to today's lesson on domain and range, which should be a review lesson from IM3 Advanced. Okay, so uh, domain and range, you can think of it as floors and ceilings. Okay, first of all, domains are x values and ranges relate to y values. Okay, and domains you can as a starting point, you can think of it as left wall, right wall. Range, you can think of it as a floor and a ceiling. Okay, as a starting point. So let's start with domains. Okay, so if you look over here, this graph forever goes left. Okay, and forever goes right. Okay, I should use a highlight here. It forever goes left and it forever goes right. So therefore, the graph never hits a left wall, okay, or a right wall. It crosses the wall, okay? So therefore, the domain is all real numbers, or negative infinity to positive infinity, or you can write it like this in the interval notation, okay? Now, if we look over here, okay, for range, okay, for range, we have we have a ceiling? No, okay? Because both arrowheads, the whole graph, I should say, keeps on going up and up and up. So it crosses the ceiling. Okay, so there is no ceiling. However, is there a floor? The answer is yes. It stops at -2, right at this point. Okay, right at this point right here. Okay, so stops at -2. Okay, and then it goes up from there, which means greater than. Okay, so it has a floor of -2. That's how I got this -2 right here. Okay, and then let me change this to yellow here. And then it goes up and up and up from there, which means it is greater than. Okay, and because it includes that -2, even though my drawing is a little bit crappy right now, okay, because I was using a tool and it didn't work out so well, but it includes that, it hits that -2, and therefore it's or equal to. All right. Now, if you look at this example, this is pretty straightforward. This is an ellipse or an oval, okay, for lack of a better term. There's a ceiling and there's a floor. The ceiling is 6 and negative. The ceiling is 6, the floor is -2. Okay? And so that's why your range is 6 and -2, and it hits 6 and -2. Okay? You have a left wall and a right wall here. Okay? A left wall and a right wall right here. Okay? So, because it doesn't cross its left, it doesn't cross its right wall. So you have -6 and +8. Okay, as your left and right wall. So that's why you have this. Okay? Boom, boom, and let me go yellow for the, okay, floor and ceiling. Now you can also write it in interval notation like this, okay? And remember, I put brackets instead of parentheses because it hits -6, +8. It hits -2, +6, okay? All right, let's look at this easy example here. Here, there is no left wall or right wall, okay? Because the graph keeps on going. Okay, I should draw some arrowheads here. Now, Desmos or your graphing calculator won't have arrowheads like I'm conveniently drawing here for you. Okay, it's just assume that you know which part goes on forever. When it basically hits, when it hits the boundaries of your graphing calculator or the boundaries or the edge of your screen on Desmos, okay, you can assume that it goes on forever. Okay, so this forever goes left, forever goes right, which means there's no left wall, no right wall. Similarly, it also forever goes up, forever goes down, so there's no floor or ceiling. So it's infinity, infinity. Okay, negative infinity, positive infinity, I should say. All right. Now here, I think this is the last example. Here we have a situation where uh, we have a point where the graph starts, and then it keeps on going here. Okay, and it keeps on going forever here. All right. Now, let's start with left and right. There is a left wall. However, there is no right wall. Okay. Sorry, I messed up. Oh, no, that's correct. There is a left wall. The left wall is 0. Okay. The right wall, there is none because it forever goes right. Okay, forever goes right. The green crosses the red. So therefore, it's infinity. Okay. Because it forever goes right. And that's interval notation there. Okay, and by the way, interval notation, when it's infinity, always just put a parentheses. Okay. That's just a rule of thumb. The idea is that infinity is a concept, and a number can never equal to infinity. So it never becomes bracket, because bracket means equal to. Okay, a number can never be equal to infinity, so it can never be a bracket. So it's always a parentheses. Okay, now if we flip this guy around, okay, we have a floor at 0. Okay, therefore I have this 0. I also have a ceiling. I have a ceiling here at 5. Okay, so that's how I got this pink. Okay, and that's this graph over here. So to recap, domains are basically left and right wall. Okay, ranges are floors and ceilings, and remember, domains relate to x, ranges relate to y's. Okay, and the walls are denoted by a number here. There's a number wherever there's a wall or floor or ceiling, and if it keeps on forever going in the opposite, in any direction, it's called, you just put infinity or negative infinity. Okay? All right, folks, thanks for tuning in.